For our senior engineering project, we wanted to improve upon the current roller coaster safety system. A typical roller coaster uses the block brake system. The block brake system is a system that divides the track into sections. The train can stop at the end of each section. Only one train can be allowed in a block section at a time. This is a safe system and it prevents roller coaster trains from colliding into each other. But there are large sections of the track where the train's speed and position are unknown. Due to this problem, we decided that there needed to be a system that continuously tracks a roller coaster train throughout the track. This system could see when the roller coaster train is not behaving properly. For example, in 2003, the Big Thunder Mountain roller coaster had an accident that killed one of its riders. The accident was caused by a wheel that fell unnoticeably off the train. With a continuous tracking system, it may be possible to tell when something like this occurs, because the speed of the train would most likely be affected. It could catch errors earlier. For example, let's say for some random reason, train 1 stops in the red oval here. Train 2 would stop at the top of the lift hill near the green arrow because the block brake system would only then realize that the next block section was occupied. A continuously tracking system could stop train 2 lower on the lift hill because it could immediately realize when there was an error. This would allow passengers to evacuate the trains a lot easier. This system could also be used for research purposes. For example, we could tell how the weather, the weight of the riders, and other factors could affect the speed of the roller coaster trains. Our solution to this idea was to put RFID tags along the track, shown in this picture as the little red dots. A RFID tag, such as this card, stores a number. When in range, the RFID reader can read the number on the card. When the roller coaster train moves over the RFID tag, the exact position of the train can be determined. The data is then transmitted via radio to the main controlling device. The main controlling device presents the data in a user-friendly way and keeps track of the position and velocity of the roller coaster train. The message is received with the radio receiver. The message is then sent to the data managing microcontroller. This device makes sure that the position and velocity of the roller coaster train makes sense. If there is a problem, the data managing microcontroller could communicate to another device to tell that an emergency stop needs to take place. The VGA and user input microcontroller allows the user to view the data that is collected and control the entire main controller. The entire system has VGA output, Ethernet to connect to other devices, and can be powered by a USB connector or by 9 to 12 volts. It has an SD card slot to access memory, LEDs to notify the user of the status of the system, and a PS2 keyboard connection. The team chose the hardware to use, which consisted of 2 Arduinos, 2 XPs, a GameDuino, an Arduino Ethernet shield, and an ID20 RFID reader. The team also did all the coding for the project. If something wrong happens with the roller coaster train, the red LED will turn on, and if connected, an emergency stop signal will be sent to other devices. Overall, the system is good. However, more powerful processors and a more powerful RFID reader could improve the system.